Now let's do a slightly, well, not more complicated because it's the same idea, but with a few more particles. And this time we're going to be calculating the entropy difference between these two states. And let's see. So there we have 20 particles in the two bulb system on the left. And then we're going to open the valve and we're going to calculate the entropy difference between this state and having 10 particles in each side. And what I'm attempting to convince you is that this is much more, has many more states, is therefore much more probable, and therefore much more likely to happen. And there's also a corresponding increase in entropy as well. Okay, so now the equation for this, good thing I'm drinking coffee because counting these states is coffee-related work for me. All right, so we'll save this space for some of the work. We'll do show you the formula here. So for n particles, the number of ways to put r in one and n minus r in the other. So number of ways to put r in one bulb and n minus r. So in this case, r is going to be 10 and n minus r, well, we have 20 particles, so n minus r is going to be 10 as well. In other bulb is n factorial over r factorial n minus r factorial. And we won't talk about where that comes from. That's in a future chemistry class called physical chemistry. But we can at least, if given these results, so that the top is going to be 20 factorial, the bottom is going to be 10 factorial, 10 factorial, and factorial, if you'll remember, means, so 10 factorial would be 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10. That's factorial. And if we do this, you actually get 20 factorial is 2.43 times 10 to the 18. And 10 factorial squared, since there are two of them, is 1.32 times 10 to the 13. And if you do that math, you get 184,756, meaning that there are 184,756 microstates. So or separate energetically equivalent ways. And again, we haven't talked about the energy part here. We're assuming that each of these particles has the same energy, so it doesn't matter which one. Like they're all the same energy particles right now. So think of it as just there are 184,756 different ways to put 10 particles in each, and there's one way to put 20 particles in one of the bulbs. So now we're going to fill this in for these two. We're going to look at it again as delta S equals S, the entropy of our final state, minus the entropy of our initial state. So S final minus Si is going to equal K times ln 184,756. And similar to the previous video, we can take these two and divide them by each other. And divided by 1, 756 over 1. And this time I'll do it out. Let's see. So 184, 756. We'll take the natural log, get 12.12679. Multiply that times k. K was 1.38. Exponent 23rd minus 1.67 times 10 to the minus 22 joules per microstate Kelvin. So that's the calculation. And you'll notice that this number, K, so as we get larger and larger numbers of particles, approximately the size of a mole, these numbers will go to approximately 1 or a 10 or 100 or even 1,000 joules per microstate Kelvin, and they'll be significant. So think of these as demonstrations of the idea of entropy, and then also think about how for moles of particles, say we had 1 mole, or let's say 2 moles on one side, and then the question is, how does the entropy change for 1 mole on each side? For moles of particles, the entropy is literally exponentially larger, which then when you take the natural log of it will lead to regular numbers, and we will see this coming up. For moles of particles, it is overwhelmingly more probable that there will be an equal distribution of particles on each side. It is overwhelmingly probable that there will be an equal distribution of particles on each side. That's an R, on each side. Meaning in each bulb. And that's great news, by the way, because that's the same entropy-driven process. That means that in the room I'm sitting or in the room you're sitting right now, there's an equal distribution of all of the gas particles, which means there's always oxygen for us to breathe. So good news.